In this example, we want to graph a quadratic function in standard form, sometimes called vertex form or graphing form, by finding the vertex, equation of the axis of symmetry, and the y-intercept. So for a quick review, this is called standard form of a quadratic function. If a is positive, the parabola opens up. If a is negative, the parabola opens down. The coordinates of the vertex will be hk, but we do have to be careful about the signs. Notice it's in the form of x minus h when the x-coordinate is h, and we have plus k when the y-coordinate is k. And if we know the vertex has coordinates hk, the equation of the axis of symmetry will be x equals h. So looking at our function, notice that a is equal to positive 1/2. So if a is equal to positive 1/2 or positive, then we know the parabola will open up. Next, for the coordinates of the vertex, notice here we have x minus 2, which means the x-coordinate will be positive 2. And we have minus 3 here on the end, so the y-coordinate will be negative 3. So one way to think of this is the x-coordinate is the opposite of what you see here with the x variable, and the y-coordinate is the same as the sign of the constant on the end. And then if the vertex has an x-coordinate of 2, we know the equation of the axis will be x equals 2. And then in general, to find the y-intercept of any function, we set x equal to 0 and solve for y. Remember, f of x is equal to y, so if we set x equal to 0, we would have y equals 1/2 times the quantity 0 minus 2 squared, or negative 2 squared, minus 3. This will be positive 4 times 1/2. That's going to be 2 minus 3, which is equal to negative 1. So the y-intercept will have an x-coordinate of 0 and a y-coordinate of negative 1. Now let's go ahead and sketch these components of our parabola. Let's start by sketching the axis of symmetry, or line of symmetry, which is the vertical line x equals 2, which would be here. Notice it's a vertical line passing through 2 on the x-axis. The vertex has coordinates 2, negative 3, which would be here. Notice again it's on the axis of symmetry. We have a y-intercept of 0, negative 1, which is this point here. And because we have the axis of symmetry, every time we plot one point, we know there's going to be a mirror image on the other side of the axis. So if this is 2 units to the left of the axis of symmetry, there must be another point 2 units to the right, or this point here. Now this may be enough information to sketch our parabola, but let's go ahead and find 2 more additional points. To do this, we'll select one other x value and sub it into the function. For example, let's evaluate the function at x equals 6. So f of 6 is going to be equal to 1/2 times the quantity 6 minus 2 squared. Well, 6 minus 2 is 4. This will be 4 squared, and then minus 3. Well, 4 squared is 16. 16 times 1/2 is 8. 8 minus 3 is equal to 5. So if f of 6 is equal to 5, that tells us the parabola must contain the point with an x-coordinate of 6 and a y-coordinate of 5. So let's go ahead and plot this point. 6, 5 would be here. Again, notice that this point is 1, 2, 3, 4 units to the right of the axis of symmetry. So there must be another point 4 units to the left of the axis of symmetry. So 1, 2, 3, 4 would be this point here. And now we have plenty of information to sketch a nice graph of the parabola. It would look something like this. And of course, we can always verify our graphs by using software to graph the function, which would look something like this. And notice how this graph matches the graph we made by hand. Okay, I hope you found this helpful.